So this is the follow on from Differentiation 2. And one of the things that we did in Differentiation 2 is we showed that when y is x squared, for the curve y equals x squared, dy by dx, the gradient function, is equal to 2x. And in this video I'm just going to change the notation slightly. I'm going to use function notation. So I'm going to use f of x equals x squared, and instead of dy by dx, I'm going to use f dash x, which is 2x. So just a slight change in notation for this video. So in this video, and in fact in the next video, I'm going to look at proving that when f of x is x squared, the gradient function is 2x. Of course, in the last video, we only actually did it for 5 points. Okay, so that's not a proof. It was good enough to get the formula, but it's certainly not a proof. So in this video, I want to do it for any general point. So I'm going to go into GeoGebra, and I've defined a general point here, x, f of x. Okay. Now to find a gradient at one point is quite difficult. So what I've done is I've defined another point, because if I've got 2 points, it's much easier to find the gradient of a line if I've got 2 points. Okay. So I've defined another point which is very, very close to this first point. Okay, and what I've said is that it's a distance of h away. So this is x plus h, f of x plus h. So this distance here, h, is very, very small. Okay, but of course, now that I've defined a new point, I can find the gradient of this line, of this chord. The chord is a line that touches the curve in 2 places. If you remember, in the last video, I talked about a tangent, which is a line that only touches the curve at 1 place. Okay, so to find the gradient of this chord is quite easy, because I can just do the rise divided by the run. And the rise in this case is f of x plus h, take away f of x, that's this distance here. And the run is of course h. Okay, so the gradient of this chord is simply f of x plus h minus f of x over h, the rise divided by the run. The problem is I don't want the gradient of the chord. I didn't really want that second point. I actually want the gradient of the tangent at that particular point. Okay? So what I'm going to need to do is I'm going to have to make this distance much, much smaller. So if I go to a new file in GeoGebra, then I've got the distance here, h, and I'm going to make it smaller and smaller and smaller. And as I do that, you can see the chord is slowly looking more and more like a tangent. It's almost becoming a tangent. Yes, so as I make h really, really small, then when it's nothing, it actually becomes a tangent. Okay, so if I go back onto Paint, then the gradient of the tangent at that particular point, gradient of tangent, so f dash x at that particular point, is equal to f of x plus h, take away f of x, divided by h, so the rise divided by the run. But of course what we did is we let h get really, really small. We let it become 0. Okay? So what we did is we looked at the limit as h tends to 0, as h gets really small. The problem is, in practice, we can't actually let it equal to 0, because if we let h equal 0, then we'd be dividing this numerator here by 0, which you can't do in maths. So we can't actually ever let it equal to 0 in practice. But what we can do is we can imagine it getting closer and closer and closer to 0, so that we have the gradient at that particular point. Okay? So this formula here is a very important formula, which we're going to use to show that when f of x is x squared, f dash x is 2x. So we're going to use this to prove that concept. Okay? So if you go to the next video, we'll do that in just a second. Thanks a lot. Bye.